Okay, this is another midpoint theorem video, and it is using the exact same screen as the one I did in the last midpoint theorem video that I did before, but there's one little thing in here that's a little bit different that's going to help us do even better. I took this from some exercise that math teachers were using, but anyways, let's just do it again. The midpoint theorem. The midpoint theorem says this, that if you have two midpoints in a triangle, that's right in the middle, say D's right in the middle and E's in the middle, they're midpoints. That means the sides of the triangle on either side are equal to each other. That's what makes it the middle, the midpoint. So DA equals DB, AE equals EC. So that is, you've joined the midpoints. Well, if you do join the midpoints, it turns out two things happen. That line DE is parallel to BC, and that line DE is 1/2 as big as BC. If that's 10, that's 20. So, and that's 30, that's 60. That's the midpoint theorem. When you've got two midpoints joined and you want to say they're parallel. But there's another part of the midpoint theorem, but we should always write, when we use the midpoint theorem, joining two midpoints, we got parallel lines and one side's half as big as the other, you write midpoint theorem. But if you've got two parallel lines from a midpoint, say that's all you've got. There's one midpoint and two parallel lines. Well, if you have that, you can say something. You can say that the parallel line, it'll hit at another place. It will hit at a midpoint. In fact, that AE will equal AC. So if you're given just these two sides and the parallel lines, you can use that to say that AE equals EC. It is the midpoint theorem, but to be correct, we should write the converse of the midpoint theorem. I was being a little sloppy in the other video. You need to write the converse of the midpoint theorem. Now we're going to look at a question, and it's very good practice for any grade 10 geometry exams. I think it's pretty good. So let's take a look at this picture, and you're given in this picture that CD equals DE, and you're given that these three lines are parallel, and there's triangles happening all over the place. That looks like some kind of quadrilateral. You've got a big triangle here, ACE. That's something to look at. Now that says, prove that AB equals BC. Prove that AB is equal to BC. But this is how I do such a question. First, I go, okay, they want us to do something with AB and BC. I put a green line around the triangle that makes sense. I'm given that CD equals DE. So I'm given this side, and I'm asked about this side. I highlight in green what's going on. And then I go, whoa, a parallel line there and there. Well, isn't that the midpoint theorem, but the converse of it? If I know that I have parallel lines in this green triangle, and if I know that this side equals this side, if D is a midpoint, then D must be a midpoint. That means AB must equal BC. I just have to give the reason. The reason is the converse of the midpoint theorem, given that they're parallel, and I've got one of the midpoints, DE equals DE. That's the answer. Now this congruency stuff can come up at any time, and it says, they might just ask you, prove that triangle CBG is similar. Ooh, I've got 4 lines in there. That's too many lines. It's just the way my math type doesn't have a nice similar thing, so I'm going to get rid of one of those lines here. There we go. Prove that triangle CBG is similar to triangle ABF. Okay, so if we want to prove that two triangles are similar, first highlight them in red. I'm going to go from C to B to G. There's the triangle. I'm going to look from A to B to F. I actually started where the angles would be the same. A to B to F. I want to prove that those triangles are congruent. Well, it's already been given that AB equals BC. We've been given that. But what else can we figure out? Well, we could say that GCB, that's the blue angle there, and the blue angle down here, I actually like to color it so I can see what I'm doing, BAF. I know they're equal because of alternate angles. GC being parallel to AF, and you need to write it just like that. Oh, but there's two angles crossing each other. Those are vertically opposite. Those green angles, GBC and GBA. Ooh, I think I might have, GBC is right. GBC is right. But it should be, I think there's just a little bit of a typing mistake there, the vertically opposite angle. If I go G, I should say FBA. FBA. Oh, that's just a little mistake there. Let's make it right here. That should be F, shouldn't it? Shouldn't it be F? Because I'm talking about this green angle. See how I name it? FBA. That green angle equals this angle, GBC. I'll have it right if I just put an F in there. So I'm going to put an F in there. And it's the wrong color, but that doesn't matter. Let's go. FBA. Angle FBA. Those two angles are equal. Well, what have I done? I've just matched up two angles and a side in the same corresponding position, in the same position. So angle, side, angle. Two angles and a side in the corresponding position. Therefore, those triangles must be absolutely equal in every way. Triangles CBG is congruent to triangle ABF. And what's the reason? Because I matched up an angle, corresponding side, and another angle. And there you go. That'd be really good to study for our exam coming up. Paper 2, really good to study.